Hi, this is Dr. Cameron Sheeler with UAB's Biotechnology program. Today, we are going to have a video on subculturing splitting cells. This is a follow-up to our critically acclaimed video on bringing cells up from frozen. Earlier today, I received a telegram that says, "We're proud to announce your frozen cell revival video has been nominated for a prestigious CRISPR award at this year's Cannery Row Intergalactic Symposium." I'd like to thank Doc Ricketts for nominating me for this prestigious award. For those of you who don't know, CRISPR stands for Cannery Row Intergalactic Symposium of Picture-Based Educational Recordings, not that other CRISPR thing. Let's go split some cells. As always, before we start, we must sanitize cell culture hood, also known as a biological safety cabinet, also known as a laminar flow hood, before we actually start our work. Let's get set up. Here we are at the water bath set to 37 degrees. What's in here? Good question. We have our growth media that has been supplemented with fetal bovine serum, FBS, phosphate buffer saline, used to rinse off our cells, and trypsin, EDTA. We have to warm up everything before we actually put them on the cells, unless we're actually isolating the proteins as we did in our previous, where the PBS is ice cold. What's our rule? It goes in the hood, you wipe it down. Squirt, 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 squirt. And you guessed it, squirt, 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 squirt. Let's begin. I've got my T75 flasks I'm going to subculture and place in. Whatever I do is I'm going to put 2 mils of the media in here because I kind of already know how I'm going to split these cells. So I'm going to put 15 minus 2 because I'm going to put 2 mils in here. So I'm going to put 13 mils of the growth media in here. Always label your flask. What am I putting in here? MDA, MB, 2, 3, 1 cells. Always put the date that you do what you're going to do. In other words, put it in. And then I put my initials on there. No, they're not Your Royal Highness. It's CQS. Now, everything that's in the paper, the plastic, it is clean. Don't touch it. 13 mils in. Let's put it in. T75 flasks that I'm using have a vented lid, so I can tighten these down. If they didn't, I'd have to keep this thing loose, the lid loose, to let air in. Now, what I'm going to do here is allow this to pre-equilibrate as I isolate the cells. So let's go put it in the tissue culture incubator.
A few minutes later.
First, we're going to aspirate out the growth media. Take our tester pipettes that have been autoclaved. Notice how I shake it. Shake it like you mean it. But you don't want to touch any of the other ones, so shake it until you can just grab one. Pull it out. Remember, you don't want to touch anywhere along this tester pipette because that will contaminate it, and then you'll get contaminated cells. I'm going to aspirate out the growth media. Just go in. Remove the media. Do not touch the bottom of the flask where the cells are. I usually rinse out each of the T75 flasks with approximately 8 to 10 mils of the warmed PBS. It doesn't have to be exact. It's not rocket science. Put it on the side. See how I'm doing that? Now, take your flask and gently rock it back and forth to kind of rinse off the cells. What we're doing is removing any like dead cells, any cell debris. Also, we're removing any of the growth media. Now, the growth media itself has been supplemented with fetal bovine serum, FBS. That will inhibit the trypsin that we are going to place in the flask. So let us shake it. There we go. I can just grab one. Since these are a little bit more confluent, I will add 2 mils of our trypsin EDTA. Remember how we push it back and peel it like a banana? I'm going to add 2 mils. Coat the bottom. And I'm going to set the timer for 4 minutes, and I'll check them in 4 minutes. You put it in the incubator during this time.
A few minutes later.
4 minutes are up, check the cells, see the progression. We can use them. If not, we'll go for another 2 minutes. I don't want the cells to spend too much time in trypsin is what I'm trying to say. Looking around the entire flask, we can see they are detached. Notice them floating by. They're rounded up bald. That's a sign that the trypsin EDTA has worked. Everything in that flask is going to be placed into 4 different flasks. I'm only going to put it into 2. Remember, I just put 13 mils of growth media into each of the 2 flasks, which means I have room for 2 more mils. So if I have 4 flasks, that means I'm going to need 8 mils total volume of the cells from that flask. We already put 2 mils of trypsin EDTA. I'm going to use 6 mils of the growth media to rinse them out. 6 mils of media plus 2 mils of the trypsin equals 8 mils. From that, I will take 2 mils out and put it into each of the flasks, hence a 1:4 dilution. Let's wash out our cells and put our cells in here and then centrifuge. I have opted to actually use 10 mils to wash out the cells. And you're going to go, why? Well, I would like to get as much media, specifically media that has FBS, to neutralize the trypsin. And what we're going to do is that we're going to resuspend the cells, centrifuge resuspend the cells in 8 mils. Then once we resuspend it in 8 mils, we'll take 2 mils of that resuspension and put it into each flask. As I stated earlier, I'm doing a 1:4 dilution, bring it up to 10 mils. That way we can really get a good wash. Start from the top, wash. Oh, you can see the media getting a little cloudy. That's great. Oh, we've pretty much got all the cells off there. Let me transfer it into our conical tube. Finish putting in our conical tube. Cap it, centrifuge, resuspend. I have just set the centrifuge for 5 minutes at room temperature, and it's going to be at 200 RCF, relative centripetal force. In other words, at 200 times G. Don't use RPMs, use the Gs. Make sure you are going to put a counterweight in there to balance it out.
A few minutes later.
There's our cell pellet. Oh, that's easily 7-8 million cells in there, easy. Let's get our flasks that have been equilibrating. There we go. We got one we can grab easy. Don't touch anything lower than there. Move the cap. Let's aspirate. Find where the top of the fluid is. Put your ester pipette on it and just aspirate and follow the volume on the way down. You do not want to disrupt the pellet, because if you suck up the pellet, you're done. There you go. So I am resuspending them with a known volume, 8 mils right here. Notice how I slowly resuspend the cells. Don't want any clumps in there. Just gentle, very gentle. At this point, we can take some cells out and do a cell count, either with a hemocytometer or a cell counter. But I already know what I want to dilute it to, 8 mils, so that I know how much I'm going to take out, 2 mils, so that's our 1:4 dilution. But at this point, even if you're growing up cells for an experiment, everything I've just did is exactly the same. You just now would count the cells so you can get the concentration of cells. See one of my previous videos on the C1, B1, C2, V2 to actually dilute them out to get the desired concentration. So let's take the cells out and plate. Spend a couple more times. Now, especially for beginners, I would highly recommend that you would change your serological after each use. Put it in that little corner. All right, now we're going to put this down and let it coat the bottom. As I like to put it down, and I go forward, backward, left, right. Do not swirl, otherwise the cells will be brought into the center. Let's do the other one. forward, backwards, left, right, no swirl. Now what do? We're gonna put it in our incubator until we need it. And I usually change the media every other day so that our little cells have all the nutrients they need and we're removing the waste material. All right, this has been Dr. Sheeler with Dr. Sheeler's Lab Shorts on how to subculture split cells and also harvest cells. Take care, and if you have any questions, email me below with any suggestions. Love to entertain new ideas. Have a great day.